Hello and welcome to Graphing Absolute Value Functions. We'll be looking at absolute value functions just in their vertex form using AHK function transforms that we've used elsewhere. First, let's look at the parent function here, y equals the absolute value of x. When our values of x are greater than 0, then that is the same as y equals x. And so we're going to get a line from the origin with a slope of 1 that goes up here. And it should be straight. When x is less than 0, when x is negative, then we're going to get y equals negative x. And that is going to give us a line with a slope of -1 that goes through the origin. And of course this line should be straight. So that's our parent function, which we could consider as a piecewise function with a vertex at 0, 0, and slopes in plural, because we have one slope to the left of 0 and one slope to the right of 0, of 1 and -1. And that becomes important as we look at our transforms. We remember that our basic transformation is going to become a f of x minus h plus k, where h is our horizontal shift, k is our vertical shift, and a gives us our vertical stretch. And the sign of a gives us reflection over the x-axis. And since we are not considering any horizontal stretch, then the vertex will be hk. In the case of horizontal stretch, then we have to solve for the vertex differently. So, given that this is what we're working with, our h here, x minus -1 would give +1, so our h is -1, and our k is -2, so we have a vertex at -1, -2. We don't have any stretch, so our slopes are going to remain what our a value is, the positive and negative of our a value. So our slopes from a are going to be plus and -1. So from here, it's going to go on up, and over here, it's going to go on up, forming our V shape, with the vertex at -1, -2. Our next problem has a vertex, an h of 2, and a k of -3. So we can plot that to begin with, 2, -3. It does have an a value. A is positive, so our v is going to open upward, but we're going to have slopes of plus and minus a, which is to say plus and -2. So up 2 over 1 to form this side, and down 2 over 1 to form this side, with our vertex still at hk because we're not considering any horizontal stretch or compression. Our last problem is going to have reflection as well as vertical stretch, but first we need to plot our vertex. So we're going to have an h of -4, because x minus -4 would give us x plus 4 when we simplified, and a k of +4, because we have +4 here on the end. So -4, +4. Here we have our vertex, and we have a minus sign, which means that our v is going to go downward. That's what -4 for our A is going to mean. So we're going to have slopes still of plus and minus A, that is plus and minus 2, but our V is going to open downward. So I'm going to start out going down 2 over 1 to make this side of my V, and it'll be up 2 over 1 to make this side of my V. So my slopes are plus and minus 2. And there's your absolute value functions in their transformed AHK vertex form.